So this is a video to support the work you're doing for the complex assignment. And remember that you've got 3 files that you're working with. You're using stddraw, which hasn't changed since we started using it a couple months ago. And then you also have complex graph. I realized that there was something I forgot to add in the complex graph, for at least the one that I gave to you. The circles are not showing up. So I posted another complexgraph.java on my website, and I'll send an email and a link with that. But the thing that you're working on, you don't have to change anything in stddraw, nothing in complex graph. What you're trying to do is you're trying to get complex to work, and it's a lot like the fraction class. So don't forget to provide a comment block, right? A good paragraph describing what's going on. You want to make sure that you put your name here. And then there are just a couple fields, just like in the fraction class where we have num and denom. We have a real part of the complex number and then also an imaginary part. And then these constructors are pretty much self-explanatory. Look at the constructors for the fraction class because they're similar, so I'm not going to spend too much time on that. And then you're going to be adding a complex number to another one. You're going to be subtracting a complex number, one from or other from whatever the current instance is. And then multiply and divide are a little trickier. And I illustrated either multiply or divide in your period, whether it was 4, 5, or 6. And again, these are the methods that are going to be the tricky ones, but it should show up working in a complex graph if you have defined those correctly. You also have to have a couple of getters, so get real, get imaginary. These are just one-line statements, and then also a setter. This is a mutator, a modifier, where you can set the real and imaginary values. Now, when you're done, when you've written all of these, this is what it should look like. So you want to pay attention as I'm running this. So complex graph. Again, you're going to pick up the complex graph that I have on my Schoology page because the one that I put in the repository was not fully functional. It doesn't show the circles. So with plus, right, if you either grab the A or you grab the B, what happens is that the real parts get added and the imaginary parts get added, and you wind up with a parallelogram. Again, there's nothing you need to change in complex graph. You are just changing the code or adding the code in complex, and then it's just going to work. And then similarly for subtraction, you're just subtracting the B values, whether they're real or imaginary, from the A values. And again, you get a parallelogram being described here. And that should be relatively easy, relatively straightforward. And of course, come and see me during office hours if you're stuck in any way. And you get not only the illustration, but also the values in the lower right. The multiplication and the division is trickier. So the multiplication, these magnitudes wind up being multiplied. So I'll choose an A value magnitude around 2, or excuse me, around 3, and then a B magnitude around 2. So 2 times 3 is 6-ish. And again, in the original complex graph, these arcs are not going to show up, so use the one that is on Schoology now. And as I rotate A in a counterclockwise direction, well, it also adds to the rotation for the result here. So you should be able to do a full rotation and see what happens. And then the same for B. As I rotate B in a counterclockwise direction, the product is also being rotated, and the result is magnitude A times magnitude B as far as distance from the origin. So you should be able to see that. Okay, and then for division, again, let me repeat, you want to use the complex graph.java that is on Schoology, not the one that is in the it's not the one that is in the repository because it doesn't include these arcs here. So you're going to get A divided by B. So if we do 9 divided by 2 for the magnitudes, it's going to be somewhere around 4.5. And as you rotate the A, it's going to rotate A over B in the same direction, just like the multiplication does. So you should be able to do that. And then as you rotate the B value, and again, I'm going to rotate in counterclockwise direction, it's going to rotate the result of A divided by B in clockwise direction. right? So in the other direction. So you should be able to see that that is happening if you've done it correctly. So you might try and compare your work to what I've got here. The tricky ones again are the multiplication and the division. The multiplication, you're going to have to do multiplication that's relatively small so that the result is going to show up, because it multiplies the magnitudes. And then the division, we do a relatively large A. And there you go. Okay, remember this is due on Friday by the end of the day. Thanks.